Hello everyone and welcome to this tutorial on building autonomous smart contracts, or ASCs, on the Massa blockchain. Today we'll cover the basics of creating, deploying, and managing smart contracts that can run autonomously. This guide is designed for both beginners and experienced developers, and we'll walk you through the process step by step. By the end, you'll understand how to use features like async call for non-guaranteed execution and deferred call for guaranteed tasks. Let's get started. Before diving in, let's quickly go over the prerequisites. We recommend starting with Massa's BuildNet for a simple setup. First, create a wallet on BuildNet from the Massa ecosystem page. You can find it at massa.net/ecosystem. For a smoother experience, we suggest using Massa Station, available at station.massa.net. Once your wallet is set up, credit it with tokens via the BuildNet faucet. You'll find detailed instructions in the documentation. This will allow you to interact with the network without needing a full local setup. For this tutorial, we'll use a local node configuration to demonstrate the entire process. You can check out the local network setup guide at docs.massa.net. To get started, clone the Massa repository from GitHub. Next, go to the directory and build it with the sandbox feature. Then generate a key pair in the Massa client. Make sure to never share your secret key. You'll also need Node.js to compile and deploy contracts. If you don't have it, download it from the official website. This local setup is similar to BuildNet, but runs offline, making it ideal for demonstrations. So far, we have seen what we need. Let's get more into the code. In this video, we won't create a new project from scratch. We'll stick to existing examples for simplicity. Also, we'll focus solely on the smart contract and set aside any front end to keep things straightforward. Let's dive in step by step. To get started, we're using the pre-existing examples from the Massa repository. First, clone it with this command. Once that's done, navigate to the Hello World folder. Great, now we're in the right place. Let's explore the project structure. Before looking at the code, let's take a moment to understand the layout. You'll notice that the smart contract is packaged as an NPM module, allowing easy management of dependencies and scripts via NPM commands. The project is divided into two main subfolders: assembly/contracts for contract code and SRC for Web3 code that interacts with the contract. Another notable file is package.json, which contains key dependencies such as Massa as SDK for writing smart contracts and Massa Web3 for Web3 integrations. These are essential tools we'll use. Now let's create the last important file, the .env file. We generate it from the .env example file. It contains various keys needed to run the script. I'll configure it to fit my setup, using my local node's API to interact with the blockchain and setting my private key to access my account and deploy smart contracts. And now, we're done with that. Let's now take a look at the code of the smart contract itself. First, we open the file named main.ts. The code starts with some basic imports, mainly from the Massa SDK. After that, we encounter the first function, the constructor. The constructor function runs when the contract is deployed. Its purpose is to initialize the contract and set the initial state. One notable aspect of the constructor is the use of the keyword export, which makes the function public and accessible from the outside. The constructor function takes a single argument, a static array of U8, which is essentially a byte array containing any arguments passed to the function. The constructor's return type is void. In any user smart contract, a static array is typically the argument type for any exposed function. It represents the serialized arguments of the function. Moving on to the function body, the first step is to ensure the constructor runs only when the contract is deployed, as a security measure to prevent unauthorized use. The function then processes the argument, deserializes it, and stores the result using the storage.set function. This function sets the value of the greeting key in the storage to Hello World. The storage module provides a persistent key value store on the blockchain that remains available for the lifetime of the contract. The function also triggers an event to indicate that the constructor has been called. Next, there are two additional functions. The first is an exported function called setMessage. It takes one argument, updates the message key with its content, and prints a message. The second function allows retrieving the value previously set. Now let's discuss the deployment script, deploy.ts. This script handles the deployment of the smart contract. The first step is to import the necessary libraries, including the Massa Web 3 library. The function retrieves the account using the private key and then reads the bytecode of the built smart contract. It serializes any constructor arguments before calling the deploy function, providing the bytecode and necessary parameters. After deployment, the function logs relevant information and waits for an event from the smart contract to confirm successful deployment. Finally, the call.ts file handles smart contract interactions. It contains a function named setMessage, which requires the contract address and account information. The function allows setting a message by calling the setMessage method on the contract and waiting for the operation to be finalized. Another function, getMessage, retrieves the message previously set. It follows a similar process, calling the readMessage function to obtain the stored value. That's the main overview of the smart contract and its deployment process. Let's run it now. Now let's build and deploy the smart contract. First, we run npm install to make sure all dependencies are in place. Once that's done, we can build the project. The contract has now been compiled. We can check the build directory where the .wasm file has been generated. That file is the binary version of our smart contract. Now that we have the binary, we can deploy it using npm run deploy. This command runs the deployment script we saw earlier. The contract is now being deployed on our local node. We just need to wait a few seconds. Once deployed, we copy the contract address so we can reference it later. We'll paste it into the .env file we mentioned before. This way, the call script will know how to access the smart contract. Now let's run the call script. As a reminder, this script calls the setMessage function with the message "Hello, Massa friends," and then reads the message back. The operation was successfully sent to the blockchain. Now we just wait for it to be finalized. And here we go. The call was a success. We can see the event that was emitted with the message, "Hello, Massa friends." Just below, we can also see that the message was retrieved correctly. That's it for this section. We've just created and interacted with our first smart contract. Now, this example has one limitation. The smart contract is passive. It doesn't take any action on its own. In the next episode, we will level the things up and talk about autonomous smart contracts. You'll find all the useful links down in the video description. If this guide helped you, don't forget to like and subscribe. See you in the next one.